All right. All right. So again, we want to know how big a loan now. We basically are going to answer the same question as before, but now the numbers are, well, different. Yeah, okay. Didn't know if I pressed record or not. So now she's making her monthly payment is $300. Is $300. So she's paying $300 a month. We have that. The interest is 9%, so we have our R is 0.09. Since it's monthly payments, right? That tells us there are 12 compounding periods per year. Okay? Remember, the number of compounding periods equals the number of payments made each year. Same thing with withdrawals if we're in the context of a payout annuity. And 6, you know, it's a 6-year loan. Again, we want to know how big a loan she can get. That's what P0 is, the loan amount in the beginning. Okay, well, we have our formula here. So we plug in our values, and now we have to calculate, just like before. Here the numbers are a little nicer. As you can see, we have 0.09 over 12. That's 0.0075, right? We have that. 1 plus 0.09 over 12, that's equal to this. 1 plus 0.0075, okay? That's what we have here, right? Again, we want to work the numerator and denominator separately. The denominator we took care of. It's the numerator we handle. So we have this. Okay. We have 1 plus 0.0075. That's what this is. We also handled the exponent, right? Negative 12 times 6 is negative 72. Now, what is now 1.0075 raised to the negative 72? That's where a calculator comes in. It turns out to be this. So we have that. Oh, sorry, wrong button I pressed. I clicked next by mistake. Sorry about that. 1 minus this. Okay, well, what's 1 minus this here? Again, you can use a calculator. We get this. You know, you could use, again, I'm using here many decimal places. I'm using 6 because in the end, I want to round to 2 decimal places. So I want to use as many as I can. I mean, I'm not going to use like 100, so I just chose 6. So now we multiply and then we divide. We end up with this. Good. So the biggest loan now she can get is this. That's the size of the loan. Okay, that's the size of the loan. Okay, so that means she can now buy a car that costs $16,000, $16,643.04. Okay, that's the car she can get. All right. So now we want to know, well, how much is she paying the loan company now? In other words, if she's sending them $300 a month for 6 years, right? How much money is she sending them in total? Well, it's $300 a month. 12 times 12 months per year, right? Times 6 years. Okay, just like before, we have to multiply by 12 months per year, and we get this product, $21,600. So she's sending them more money, which you would expect because the loan now is longer and the interest rate went up. And again, how much interest is she actually sending them? Well, it's the amount she's sending them minus the loan amount. You know, that's the total amount of interest, which is this. That's what happens here. Okay, that's good. Now, any questions on this? Because I figured we'd do a little bit of that 5-number summary stuff. Okay. All right. So now this is just a reminder how you actually find quartiles, right? Remember, if n is the number of data values, we follow this, we follow this whole procedure. It's the 5-number summary. That's what we get. That's what we get here. So now, and again, this is the process. Remember, for Q1, you're doing L is equal to this, 0.25 times n. N is how many data values you have. And whether L is a decimal, like 5 point something, 5.8, 5.9, or if it's a whole number, that determines what you do next, as indicated. Okay, that's what happens here. Q3, right, is the same idea, except your L is 0.75 times n. So for Q1, the first quartile, you're doing this process for 0.25 times n. I know I'm not going through all the details here because, you know, we have done this before. For Q3, the third quartile, you're doing 0.75 times n. And the median, you could use, we did actually see another procedure, but you could use this. It's just that your L would be 0.50 times n. Okay. So that's what we get here. Okay. So now that we have that, let's get the 5-number summary. So here's our data. You know, these are numbers. You know, how do we get these? I don't know, but for now, that doesn't matter. But it turns out there are 18 data values. You do have to sort the data. Hope I put that in there. Well, sorry. Did I? Yeah, I did. You order from smallest to largest. You always want to sort the data. You can easily do it using Google Sheets. I showed you how to do it. Here's the process as well. As you can see, we have that. We're sorting the data. The data is sorted already, excuse me. Now, we get a 5-number summary. Okay, so we're going to use that process, like so. So the minimum, right? That's your first number in the 5-number summary. Okay, the process from before, that was the quartiles. For the 5-number summary, it's the minimum, the first quartile, the second, which is the median, the third quartile, and the maximum. You know, we have seen this before. The minimum is 1. The maximum is 20. Okay. Now for the first quartile, right, we're basically going to use that procedure. I almost said algorithm, but I guess it is an algorithm. But we're going to use this procedure with L as 0.25 times n, but n is 18. There's 18 data values. So we have this. 0.25 times 18, that's 4.5, which is the decimal. So because of that, we're going to round up to the next number, which is 5. That tells us the 5th data value is the one we use, and it turns out to be 5 as well. 1, 2, 3, 4, 5. So the 5th data value is our first quartile. Let me say it again. I went kind of quick. For the first quartile, we have to calculate L, which is 0.25 times n. N is 18 in this case. That's how many data values there are. That product is 4.5. This is a decimal, so you round up to the next to the next largest whole number. Even if this was 4.2 or 4.1, you would still round up to 5. for this procedure. For 5, okay, so we end up getting 5. That tells us the data value, the 5th data value that is the first quartile. So we have the 5th data value, 1, 2, 3, 4, 5. So we get 5. Q1 is 5. For Q2, the median, right, it's the same process except L is 0.5, 0.50 times N, 0.5 times N, and you get 9 here. Now that's a whole number, right? Well, in that process, let me go back to it. If you get a whole number, you're going to find the mean, which is average, of the L and the L plus 1, excuse me, the data values in the L and the L plus 1 position. If it was a decimal, right, we round up to the next whole number, as we did. You know, even if it was 0.1, you would round up. If it's a whole number, you get the average, the mean, that is, same thing, of the data values in the L and L plus 1 position. So we get the data values in the 9th and 10th position, because L in this case is 9. So we get the data values in the 9th and 10th position, and we get their average, which is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10, 11. Now, excuse me, 10, which is 11. Sorry, I got messed up. So we have the 9th and 10th data values, which are 10 and 11. We need their average down here. Okay? So we get 10.5. That's the median. Q3, okay? L is 0.75. So we do 0.75 now times 18. 0.75 times N. N is the number of data values. So we have 0.75 times 18, which is 13.5, which is a decimal, right? It's not a whole number, so we round up to 14 in this case. Then, right, what do we do next? Well, we round up to 14, and we use the data value in the 14th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're going to use 16, as you can see. That's in the 14th position. That's our Q3, right? This is a decimal. So it's a decimal, just like up here, we round up to the next whole number, 14. We're using the data value in that position then, in the 14th position, which is 16, counted from the bottom. So our 5-number summary is the min, Q1, Q2, Q3, maximum. These numbers.